So here's going to be the video solution for the second practice quiz that I gave you guys. We're doing the free fall, and the first problem we're talking about a ball being tossed from a height above the ground. So here's our setup. We have that initial height of 1.5 meters, traveling at 15 meters per second. The ball, of course, is going to go up, and it's going to hit its peak, and it's going to come back down to the ground. The first question wants us to find the maximum height that the ball reaches. So let's talk about what we know about the way up for this object. We know the initial velocity is 15 meters per second. We know that g is going to be slowing me down, so it's going to be negative 10 meters per second squared. We know the initial height, or d0, for this object is 1.5 meters off the ground. And because everything, when it gets to the very peak up here, is traveling with a velocity of 0 meters per second, well, I know that the final velocity on the way up is 0. So I need to find an equation for distance that's going to use the final initial velocity in g, and then account for the fact that we started above the ground. So the equation that does that is vf squared minus vi squared over 2 times the rate of acceleration, or g in this case, since it's free fall. That finds the distance we traveled. So look back at our diagram, that's going to find the distance from the initial height to the peak of the motion up there. Since that doesn't take into account the distance we started above the ground, we need to make sure and do that. And to do that, all we have to do is add in d0. So we can plug our values in from here. Vf, we know, is 0. Vi is 15 meters per second squared, all divided by 2 times negative 10 meters per second squared. And then we'll add in the 1.5 meters to account for our initial height. If we solve all of that, we end up with 12.75, but since we only have 2 significant figures, we're going to say that our ball ends up 13 meters above the ground. The next question asks for our speed at impact, so that's going to be down here on the way down. The only thing I really know about the way down is that the initial velocity is 0, and now I also know the distance that I fell. The distance that I fell is going to be the 13 meters that is from the peak up here to the ground over here. So we do have an equation that allows me to find Vf just based on the distance in free fall. So we're looking for the final speed, or the impact speed, and that is the square root of 2 times the acceleration due to gravity times the distance we fall. So from here, it becomes pretty easy. You just plug everything in. 2 times our 10 meters per second squared times our distance of 13 meters, and we get a final velocity of 16.1, which with 2 significant figures is only going to be 16 meters per second will be our final velocity, or impact speed, on the way down. The third question is, how long does it take the ball to hit the ground after it leaves the person's hand? So there we're looking for the time for the ball to be in the air. Now, because we start at one height and we end at a different height, that means that the time in the air, the time going up and the time going down are going to be different. So we need to solve for each one. T up and T down. So T up, on the way up, actually becomes pretty simple because we know the final velocity, the initial velocity, and the rate of acceleration. We can find the time by simply doing Vf minus Vi divided by g. Since we also know that for the way down, we can find Vf minus Vi over g. and find the time for both directions. So the time up would be 0 minus 15 over negative 10, or 1.5 seconds. The time down would be 16 minus 0 over 10, or 1.6 seconds. Adding those two together, you should have a time in the air of 3.1 seconds. So the last question asked me to go back and figure out where is the ball at a given point in time. So I am going to, so let's shrink some of this down a little bit and move some things around. To find the position of the ball at any point in time, I gave you guys an equation. We know an equation for the height, for distance, based on time. That equation looks like VIT plus GT squared over 2 plus the initial height of the ball. This is the height of the ball, or D, based solely on time, because we know the initial velocity of the ball and we know the initial position. So what this is really doing is giving me an equation that's going to solve for how high something is, that D, based strictly on how long the ball's been in the air for, or T. So for this problem, I asked you to find D when T is 1.2 seconds. So all we really have to do is plug in all our values for the entire thing and solve for D. So D is our initial velocity, which is 15 meters per second, times the time of 1.2 seconds, plus G, which is negative 10 meters per second squared, times 1.2 seconds squared, plus our height off the ground, which is 1.5 meters. Now the key here for this entire thing is this part. G needs to be negative in order for this to work. The reason G is negative is because initially that velocity we set is positive, which means when we're moving upwards at 15 meters per second, we're moving with a positive velocity. In order for the object to slow down as it gets towards its peak, the acceleration needs to be negative. So G is going to have to be a negative term in order for this to work. So from here, it's basically just plug it into your calculator and find a solution. So the answer for the distance, sorry, I need to shrink this down a little bit more. The distance the object traveled, or the distance the object is at, the height above the ground the object is at, is, so the distance you would find would be 12.3 meters without the right number of significant figures. So the distance with the right number, though, would be 12 meters above the ground. The key check here is to note that the maximum height reached is 13, and our height that we found is slightly below that at 12 meters.